Hi, hello. My name is Daniel Tay, and my partner for this final assignment is Meihui Lee. This is our final assignment for our forecasting normal assignment, and today we'll be looking at energy data. So, our data set is taken from the Australian Energy Market Operator, AMEO, where we got the demand of energy, and specifically in the state of Victoria. So, our data set we got both demand and price data for Victoria from January 2010 to September 2019. So our purpose of the analysis is to find the best fitting trend model and to give predictions of electricity demand in Victoria over the next 10 months. So we first look at the data set. So when we plot it out, we look and we note that the trend is downwards. There's obvious seasonality. There's no change or intervention point, and there's no change of variance as well. So when we plot the ACF and the PACF, we can see that the seasonality in the ACF plot and the first significant spike uh, is it's over the blue line in the PACF. So we understand that our data set is not stationary. So we test that out using an ADF test, and that confirms that with a p-value score of 0.45. So at this point, what that tells us is, we look next and see if which models we may use in the future. So whether that needs differencing and Box-Cox transformation. So in our next slide, we did a Box-Cox transformation, and visually it seems like it didn't change much. And then when we did the ADF test again, it is still not stationary. And the next thing we did was also try to difference it, but then we lose the seasonality. So at this stage of our assignment, we're highly likely to keep the data as is. We want to keep the seasonality and forecast that out. So the next step that we did was to start looking at distributed lag models and also ETS models. So distributed lag models. So as mentioned in my first slide, we also took price data from the AMEO website. So electricity demand and also price. When we plot them out in a scaled view, you can see that it actually contradicts each other. You can see that price is actually going up and there's a big spike here, but it's trending upwards. Sorry, not going up. It is trending upwards, whereas we know our demand graph is going down, is trending downwards. And when we check the correlation of the electricity demanded and price, series does not appear to follow each other closely. And the correlation given is negative 0.38. However, we will continue to do our distributed lag models with this data and explore, the results of the model. However, at this stage we know that due to the poor correlation, it's probably not the model that we're going to select. Anyhow, at this stage we have tested out three distributed lag models. The first one being DLM. You can see the intercept is significant, poor adjusted R-square score, but we have p-value that is significant as well. When we look at the residuals of the DLM model, you can see, there's a big spike over here that looks like an outlier, but our lags are all still very significant. And although the histogram slightly, you could say it is distributed evenly, due to the ACF lags being significant over the blue line, we can consider this not a good model. So the next thing we did was an autoregressive distributed lag model. Now again, we look at the p-values, has a better adjusted R-square model, R-squared of 0.67, which is good, and our p-value is under 0.05, so significant. That's good. We look at the residuals. Again, we can't really get rid of the outliers, but the residuals seem to be smaller than the first model. Like it's spread out, and if you take the outlier out, it does seem to be just, contained within, from 0 to under 50, or slightly less than 0 and under 50. So it's good. It's spread out in a rectangular shape if you exclude this outlier. ACF lags, they're good. They're all, they're all underneath the blue line, so it's good and not significant. And the distribution, it's not really, you could say it's close to normal, but not really. And that outlier out there, it's still showing. So to recap, this second autoregressive distributed lag model probably looks better than the first one, the DLM. We also did the Coic transformation model. It has a poorer R-squared 0.48, the p-value is under 0.05, intercept significant. Residuals, again, it looks almost similar to the first DLM model, where but I would say it's better. It doesn't jump around that much, except again for the outlier. However, yeah, the ACF, you still have a significant lag on the 12th lag, so it still sees, it's still still not taking out the seasonality, and the distribution of residuals, again, pretty similar to the previous two. So at this stage, these are the three models we have explored. It looks like out of the three, the autoregressive distribution lag model is better at the moment. But let's look at ETS models, or exponential smoothing models. So again, we've tested three so far. The first one we did was the Holt-Winters additive model, a May score of 0.46, and we look at the residuals. It's not too bad. It is, spread out across a rectangle shape. There's a slightly significant lag here, but it's just ever so slight. However, residuals, the distribution, it's not normal. You can see that it's not normal. We did the Leung box test, and we got a p-value score of under 0.05. Next was to do ETS MAM. Sorry. And again, we have a mesh score of approximately the same as the Holt-Winters model of 0.6787. When we look at the residuals, again, similar, just bounces around, spread out pretty evenly, so not too bad. There's one significant lag here on the third, but our 12th and 24th lags are, good. And again, the distribution of this is still not normal. And again, Leung box test, we have it's under 0.05. Last one that we did was the ETS MMMM. Again, similar May score, similar residuals, and again, it's very similar to the MAM in all counts. So at this stage, we are still exploring which models. What we'll do next is to tweak our ETS and try additive modeling. But for now, we modeled Model 6, Model 6 being the last MMM model. And, right now it looks all right, but we will continue to do our diagnosis and testing of models. And hopefully at the end of the presentation, we will be able to confirm which model we're using. For now, and by doing that, we'll be comparing the AIC, BIC scores, and also comparing MACE and taking into account MACE scores as well, and also looking at the residuals. Thank you.